This section and the next section are purely Algebra 1 review. As such, I won't be going into as much detail as I might with a regular lesson. Here you can see the outline of the review topics I'll be going over pretty quickly. Hopefully all of those look familiar, although from experience I know the last two items are often the weakest for students. So if you need a refresher, you've come to the right place. First up is slope. Slope measures how steep a line is. Generally speaking, we will be talking about lines plotted on a Cartesian plane. If we look at this line going from left to right, it is going up, and it will have a positive slope. If instead we have a line going down from left to right, then it will have a negative slope. I'll deal with horizontal and vertical lines in a bit. To find out how steep a line is, you probably remember that we do rise over run. It is important to know that slope is abbreviated with a lowercase m. You might be wondering why slope is abbreviated with an m, and nobody knows. Most likely it was just a random letter, but no one knows for sure. To figure out the rise over run, the first part is to find two places where the line crosses exactly at an intersection in the graph, whole numbers. If the teacher is giving you a problem where the line never crosses in two perfect spots, well, either they are making you estimate the answer, and they should specifically say estimate, or they are just evil. From here, we build a little right triangle connecting the dots. The horizontal side of the triangle is called the run. Since this side of the triangle is going from left to right, that's the positive direction. And it has a length of 5 here, so the run in this case is a positive 5. The vertical side of the triangle is called the rise. Here the rise is going up, which is the positive direction. In this example, it is rising positive 4 units, so our rise here is 4. Since slope is rise over run, we put the 4 over the 5 and get a slope of 4/5 in this example. Now we get to the slope formula, which hopefully is familiar to you. Given 2 points, the slope is y2 minus y1 over x2 minus x1. You get to decide which of the points you want to be x1, y1, and which one you want to be x2, y2. If I decide to make the bottom left one x1, y1, and the top right one x2, y2, then my slope becomes 3 minus negative 1 over 2 minus negative 3, which ends up being the 4/5 that we calculated by hand before. Just to show you that it doesn't matter which points you choose to be x1, y1, and x2, y2, if I switch up the points, then the slope formula ends up at negative 4 over negative 5, which simply simplifies into the same 4/5 answer we have calculated twice before. So it doesn't matter which is which. But students do sometimes go one direction for the top of the fraction and then switch directions for the bottom of the fraction. That won't work. Make sure you go the same direction both times. Now let's quickly look at horizontal lines. And on this horizontal line, I will plot 3 random points. Slope is supposed to show how steep a line is, but the horizontal line is flat. There is no slope. If you plug 2 of the points into the slope formula, you find that it calculates out to 0. That should make some sense. It's flat. It has no slope. I could have used any 2 points since the top of the fraction would always be 5 minus 5. What about the equations of horizontal lines? I have plotted 3 points here to illustrate that for all 3 points, the y value doesn't change. In this example, y is always 5. X keeps changing, but y stays the same. X is actually irrelevant and doesn't even show up in the equation. The equation is simply y equals 5. This leads to a common mistake from students. Students associate x with the horizontal axis, which is fine. It is the horizontal axis. However, the equation for a horizontal line is y equals some number, and so students often mix that up. But if you plot out the points, you will see that it is the y values that stay fixed. So the equation for a horizontal line is always y equals some number. Now let's switch gears to vertical lines. And this one gets a little trickier due to its slope. With horizontal lines, it made sense for it to have no slope since, well, it was flat. Calculating the slope with the formula gave us a nice confirming logical answer of 0. No slope. 0 slope. Great. However, with vertical lines, it isn't so logical. The first question to ask is how steep is a vertical line? Really, really steep? Super steep? Crazy steep? Some grade school teachers teach that it is infinitely steep. That's definitely in the right ballpark. It is infinitely steep, but you can't put that as an answer. Some grade school teachers do allow that as an answer, and I'm definitely not on board with that. For the reason why, let's see what happens with the slope formula. No matter which points you select as x1, y1 and x2, y2, you end up dividing by 0. Heck! Dividing by 0 is simply really, really bad. It crashes most calculators with an error, and so much more. So unlike horizontal lines, we don't get a nice satisfying answer from the slope formula. We can't say the slope of a vertical line is crash, or ack, or kaboom. The math vocab word you need here is undefined. I know that isn't as satisfying as horizontal lines being a slope of 0, And an infinite slope may make more common sense, but mathematically the slope is undefined, so that's what you need to start learning to put as the slope of any vertical line. As far as the equation of a vertical line, if you look at the points I have plotted, you will see that this time it is the x values that are fixed. They are always 4. The y values change no matter at all. Just like the equations of horizontal lines, students often get these backwards. The equation of this line is x equals 4. The equation of any vertical line is x equals some number. That's backwards from many people's instincts. Horizontal lines are y equals some number, vertical lines are x equals some number. Keep that straight. And if you forget, just plot out a few points and see which values are staying the same every time. The first form of an equation we'll do is slope-intercept form. Of all the forms, this is usually the most recognizable, and students almost always feel the most comfortable with it. Just like before, slope is abbreviated with a lowercase m, and it is the m in y equals mx plus b. The b stands for the y-intercept. Once again, there is no good reason for why b was chosen to represent that value. And x-intercept is where the graph will cross the x-axis. Similarly, the y-intercept is where the graph will cross the y-axis. Most of you are probably most familiar with this form, so I won't linger too long here. If I wanted to graph the equation y equals negative 3/5 x minus 2, you first need to identify the slope as negative 3/5 and the y-intercept as negative 2. Start with the y-intercept. Since the y-intercept is negative 2, start by plotting this point. Now we will use the slope of negative 3/5. That's rise over run. I can use a rise of negative 3 and a run of positive 5, or a rise of positive 3 and a run of negative 5. It doesn't matter. I will do the former. So I am going to do a rise of negative 3. Negative rise means go down, so I go down 3 units. Now I have a run of positive 5, so I move 5 units in the positive direction. That's to the right. That will get me a secondary point on my line. From there, you just play connect the dots, and that's how you would take a y equals mx plus b equation and graph it. Moving on to point-slope form, which is something many students are not usually as comfortable with or don't remember at all. The name kind of helps explain when it is useful. We did slope-intercept form, and that name was also helpful. It has the slope and y-intercept right there in the equation. Here we have point-slope form, which is good for when you have a point and the slope. First, the slope is still m. That, thankfully, is very consistent. In this form, it is slightly confusing that there is a y and also a y1, as well as an x with an x1. The x1 and y1 are from some point on the line. We take the point that we know and we put the x-coordinate of that point in for x1 and the y-coordinate of that point in for y1. It is important to note that the formula has minus signs in it. When you put x1 and y1 into the formula, you have to flip their signs. That's best seen in an example. Let's say we need the equation of a line with a slope of negative 4/7, which goes through point 4, negative 9. Since we were given the slope and the point, it's the perfect time to use point-slope form. The slope simply replaces the m in the formula. The 4 needs to go in for x1, but with the minus sign there, we have to have x minus 4 there. The negative 9 needs to go in for the y1, but we flip that sign too, so we turn it into positive 9. Altogether, we end up with this equation. Make sure you realize how the information was plugged in to get that final answer. So that's one way to use point-slope form. How about if we had to graph it? Here is another point-slope form equation. Y minus 2 equals 2/3 times the quantity of x plus 1. Just like y equals mx plus b gives you 2 immediate pieces of information, this equation in point-slope form also gives us 2 pieces of information. The slope is pretty easy. It is simply 2/3. However, remember that the formula has minus signs in there that flip the signs. So when we want to know what point this line goes through, we have to flip the positive 1 to negative 1 and the negative 2 to a positive 2. This means that we know the line goes through the point negative 1, 2. We have a slope of 2/3, so we use rise over run to find a second point on our line. In this case, a rise of 2 and a run of 3 gets us to point 2, 4. From there, we can just play connect the dots, and that's how we would graph a line given point-slope form. And now we finally get to standard form of a linear equation. I am just going to say standard form for short, but technically the full name is necessary since the term standard form comes up a lot in math. There are standard forms for quadratic equations, scientific notation, polynomials, and so much more. You would also think by the name that standard form would imply it's the default and/or the best form, that it should rule over all the others. It's the standard. However, it is clearly the least useful. It definitely seems the most formal of them all, as it has stuffy standards, but definitely the least useful primarily because it doesn't give us any information right off the bat. Both point-slope form and slope-intercept form give us two pieces of information about the graph just by looking at it. And that just doesn't happen here. The slope will end up being negative a over b, but that takes a little bit of math. The slope for the other two forms is just sitting right there in the open. In addition, standard form has these restrictions. A, b, and c have to be integers, and a also has to be positive. Like I said earlier, it seems a bit stuffy and formal to me. But since you will see it here and there, let's see how you would actually use it. Mostly at this stage of your math career, that means graphing it. Here it says we are graphing 4x minus 2y equals 8. Notice all the numbers are integers, and the number in front of the x is positive. Lovely standard form. The best way to graph this is usually to find the x and y intercepts. The y-intercept will be when x is 0, and the x-intercept will be when y is 0. So basically you solve twice. First by setting x to 0, and seeing what y is. This is what that looks like. With x equals 0, we see that y ends up being negative 4. So we know one point of our graph is at 0, negative 4. Setting x to 0 found our y-intercept at negative 4. Now let's find our x-intercept. This time we set y to 0. Running through the algebra shows us our next point is at 2, 0. That's our x-intercept. From here we just play connect the dots again, and that's how you would graph a standard form equation. That's all the algebra review for this section. Section 3.8 is also algebra review.